So let's get started with our Git training, and maybe a few housekeeping things at the start. I think we're dealing with a few different levels today, that some of you might have used GitHub quite a bit during your studies, and some of you are very new to GitHub. So we thought that it might be interesting for those of you who are more advanced Git users, that maybe if the start what we do is not that interesting for you because you already know all these things, that you can start a conversation, a chat about things you're interested in, and maybe some other more advanced GitHub users are also interested in that. So that you can do that on the side while we are starting with the basics. And also Edric will support you through the chat. And also Jordan and I, while we're not teaching, we're also going to be there in the chat for any questions. And also if you have a question or if you don't, something doesn't work, feel free to unmute yourself and just mention it, because same as for the basic Linux learning, it's super important that you can follow along with the basic steps, because those are crucial to make use of GitHub. So I'm going to start sharing my screen. So an introduction to GitHub is, why do we use GitHub and why do we need version control? And we think that graph is pretty explanatory. And I think everyone, when using Word, has been in that situation, that you have like a final version, then you have the revised version, and you just have tons of version after each other. And it might get pretty confusing. And to amend that, version control is really useful. Word also introduced their own version control. I guess everyone might know track changes. But the problem of track changes is that once you accept track changes, it's not easy to revert them, or to just revert some of the track changes. So the beauty of version control using Git is that you can revert to a different state. Let's say if you messed something up and you don't know how to fix it, you can just revert to the state before you made a mistake. And that's why Git is a very powerful tool. And it is also useful when you use supercomputing, because Jordan will go more into detail for that. You can push it from your local machine to your remote repository and the other way around. And that will be really useful when you're wanting to move files from your local machine to the supercomputer and back. So let's get right into Git. Let's all get up our command line. And it's important again to use Linux or Unix or Mac command lines. So the Windows PowerShell or the command line which you get when you type cmd will not do. And maybe let's all run a quick check if we have Git. So if you type git --version, it should print your Git version. And if you don't have Git installed, you will get an error message. So it would be great to get a thumbs up, or otherwise just unmute yourself if you don't have Git installed, because that's a prerequisite to get started.
Are we supposed to be working on the clusters today, or is it okay to work on our home desktop?
It's fine to work on your home desktop for now. Jordan will walk you into an exercise later on where you need the cluster for, but so far it's only on the local machine.
Yes, so everything on your local for now, and if we get time at the end, we'd love to do sort of an interactive activity where we interact with our locals and the supercomputers.
I do not have the module locally, so is it fine to use the cluster for this first part of the exercise?
I think it should be okay. You can do everything on the cluster that you can do here.
Right.
Might just, it'd probably be, it's ideal, I think, at this point, if you can use your own computer. So Ivan, if you'd like a hand of that, we could just jump into a breakout room quickly. And also Caleb, if you'd like to join me in the same room, we can have a look at your error. Sorry, guys.
Yep.
Should I move you in a breakout room, or can you do that, Edric?
Jordan, would you like to sort that out?
Yes, I'll do that. Continue
So
on.
I will keep going for everyone else, because I think everyone else was positive with being set up for Git. So for those of you who already have had a GitHub account since a while and didn't set up a new account, maybe have a look at which settings you already have on your machine by typing git config --list, and this will show you settings that you already have on your machine, like global settings, and for the other ones we will set them up in a minute. And you can also follow the setting up in the second section of the text that we shared with you on Slack. So for those of you who are new and have never used GitHub before, you have to link the Git on your local machine to the account that you created online earlier. So the first is to link your username. And for that, you will type git config again, which just stands for Git configuration, and then --global. You can also copy the commands from the text if it's easier, and then user.name, and then in parentheses your own username. Like for me, the username that I chose when I set up my account is mnsphere, but you would type your own individual username and then enter. And then you would do the same for your email address. You would type git config --user.email, and then again your individual email address. Which will obviously be again different from my email address. Right, I have to close the breakout rooms because I can't see my screen with the breakout rooms open on top. Oh yeah, I forgot to type global, sorry. I wasn't seeing what I was typing because the breakout room allocation was on top of my screen. So config --global and then username. And yeah, if your screen gets messy as it did for me, just type clear. Another good thing to set up is line endings, because line endings are different on a Linux and Mac OS machine. They are in one form, and they are different on a Windows machine. So if you're using Git Bash, you would type the command git config --global core.auto crlf, because crlf is the line format for Windows, and then through. And if you're on a Linux subsystem or a Linux machine or a Mac OS machine, you would type git config --global core.auto crlf input, which means that if you have an input file from someone else who might have worked on it that has the crlf ending, the input will be automatically converted to the LF ending, which is the macOS and Linux ending. But depending on your machine, also take care of this setting. You can also set more settings that you can have a look at in the text. Like you can set your own favorite text editor, or if you're working with a proxy, you can also set the proxy details in the with the config command, but this is above the scope here. The only command that is also of interest for us is git config --global init default branch main. This is more of a convention thing than actually needed, because for GitHub, the main branch used to be called master, but the name is not really adequate anymore. That's why it's changed to main, and it's good practice to have your branch called main. And you can also set that with that variable. And once you did all those steps, you can double check it when you type git config --list. The most important configurations which actually enable you to use your username and your user email. And I just noticed when I entered it blindly, I entered my user email wrong. So I will just fix that with git config global user.email. Forgot the student in my email. So now I double check again. And now my email and username are correct. So the other settings are not as crucial, but in order to do the steps with the remote repository later, you need to have entered your correct email, and you have to use the email that you used to set up your account when you created your GitHub account, and the username which you chose when you were also setting up your GitHub account. And once you have done those steps, you're ready to go. Maybe just a thumbs up or unmute yourself if you had problems with that, because you need those settings in order to use Git. At least the two first main settings with the user email and the name.
I don't have the core.eol equals ls. Is that important?
I did that for my, it's not that important, but I was annoyed by a command that was saying that my lines are being converted. And this is because it's a bit tricky when you have a Windows machine, as I do, but a Linux subsystem. So if I would run some Python code and I would like edit it in a text editor, which is not my nano editor or another editor which I use in the Linux subsystem, but which I use in my normal Windows system. And then when I make other files that I edit in my Linux subsystem, I have the crlf command. So this covers like both ways when you have a Linux subsystem. So you can use this setting, but it just suppresses a warning in the end. So it looks prettier, but it won't make a difference, or it won't make your code go wrong or anything. Yeah, but if you want to set it, you would type git config --global and then core.eol and then lf.
Okay,
but
awesome.
If you want to set it, you can do it that way.
Yeah, but there's no like functional difference.
No, because it always converts it from the file endings, except if you set core autocrlf to false, that's bad. But if it's not set to false, it always converts the endings. But if you don't have it specified, it will always give you a warning later on. And this can get a bit annoying.
Yep, okay, thank you.
Anything else, or is anyone good with the settings? And then we will go on to start to actually create a repository. This is when you're following the text on your own screen, section 3 called creating a repository. So now we are actually starting to work with Git. So let's make a directory with the command mk0 for make directory, and let's call it planets. And enter. So now if we do the ls command, we can see that we have our new directory planets here. And let's move to the directory with cd. And now we have an empty directory. And now we want to initiate our directory as a Git directory. And to do so, we type the command git init. And you should get the message initialize empty Git repository. And you can see that at the end of the command, there is the .git file. And if you type ls show all, so it also shows hidden files, you can see that now you have a .git file in your repository. And the .git file is the file which will be tracking your history and the one that enables the version control. It's actually a directory, and we will later have a look at it as well because the directory has all your information. Another command, which is good practice, it's not necessary, but it's good practice, is to double check or to force the branch you're using to be called main and not master. We type git checkout -b and main. And now it says explicitly that the new branch is called main. But this should actually be set via the init default branch main setting. But just in case you didn't set it or anything, you can explicitly do it via the checkout command. And one very important command when you're using Git is Git Status, because it always shows you the status of all your files and your folders. So let's give it a go. It might be confusing with all these commands at the beginning, but you'll get used to them, and you can also have a look again at the text in your own time. So the status command currently, because we haven't done anything, shows that we're on the branch main, as we defined before, and there are no commits, and there's something with git add, and what commits and git add are and will be explained now. And one comment as well for Git repositories. If we check with LSA, we can see that we have the Git file here. And if you would want to create more files within the planets directory, you do not need to make a git init command in every directory, but this would actually get messy. But the top directory planets will be tracking all the subdirectories and the respective files. So you only need to initialize the head directory with git init. And if you would want to delete the directory planets after you have worked with it and done some Git stuff, you cannot delete it. But if you would want to, you would have to first delete the .git file with the command remove recursive force and then the .git. So you're forcing to delete the file, which can be dangerous. And after running this command, you can remove your planets folder. But we're not going to do that now. This is just in case when you make a mistake for creating a Git repository and you want to delete it. But use the forced remove with caution. So now we have initiated a repository. So now we can move to tracking changes. maybe just to double check if everyone was able to initialize a repository, maybe send a thumbs up in the with the reactions. Or if not, send something in the chat, or a message, or unmute yourself if you had problems. Looks good. So now we are in section 4, tracking changes, because so far we have initialized a Git repository, but we haven't actually done any changes. So make sure that you're in your planets directory on your machine. And now we will use the nano text editor to initiate a file called Mars. Just to stick to the theme of planets. And enter. Now we have an empty Mars file. And let's say this is information about Mars. And then we save it with Control-O, enter, and then Control-X to exit the nano editor. And then with cat mars.txt, we can see that now we have a Mars file with the sentence that we entered. You don't have to enter the same sentence as I did. It's just an example. You can enter anything to just simulate that you made a change. And we can also see when we type ls that now we have mars.txt in our file. Now let's go back to the command that I mentioned before, that if you ever want to check how your Git tracking is going and what is being tracked, that you always default to the command Git Status. And now we get all those messages here that we don't have any commits, but that we have untracked files. Untracked means that they are not tracked with the .git file yet. And we can see that this is the case for our new file that we created called mars.txt. And in order to add something and do commits, Git has a two-staged process, which I will elaborate on later. So now, as suggested in the untracked changes command, we will add our file by typing git add mars.txt. A comment to the add command. Let's say you wouldn't have just one file that you want to add, but you would have a list of 10 files. You might not want to type the name of every individual file, but if you want to add all of them, you can just type git add dot, and then everything which is listed under untracked files on the list will be added. And now let's type git status again. And now we can see that now the new file is suddenly turned from red to green, which means that the file has been added. Adding a file means that you have the intention to save the changes to the file, but you haven't actually saved it yet. But actually saving the file would be called committing it. So let's do the actual saving now with the commit command. So you would type git commit -m. -m just stands for message, because it's good practice when you work on a file to add commit messages, which should be concise, but that they should also be precise and explain well what you have done in the commit. This is necessary or useful that if you want to go back later and have a look at your different versions, that you can understand what you have done, or if you're collaborating, you can understand what your colleague has done. So let's call it, we started nodes on Mars. and enter. Now we get this message that I got committed. And if we would run again the Git Status command now, we would see that now there's nothing to commit because everything has been saved with the commit and the previous git add command. You can also check your commits with the git log command, which shows you the log of all changes. And now we can see under the log command that who the author was. So you will see your own username and email. When did you do it? And your commit message, which describes what you have done in the respective step. To make it more understandable, what maybe it might be a bit confusing at the start. Why do I have to add first and why do I have to commit afterwards? Why can't I just do it in one step? I will share a figure for that. I think now you should all see the little Git figure on your screen. And the Git add, it's like you could compare it with taking a snapshot. So when you do Git add, you choose the area of your snapshot. So which area do I want to take the snapshot on? Because maybe you just want to snapshot this part, but the rest of the page you don't want it. So you focus on that area. And you tell Git that you have the intention to save the changes for those specific files or folders for that specific selection. And when you use the commit command, you actually actively take the snapshot to stay in the example. So you actually save the changes. And only giving the intention to take the snapshot or to save the changes is called staging. And that's why this is called the staging area. And let's go back to the command line. Let's do another change to our Mars file. Or has everyone any questions about adding and committing? Or was it clear that there's like a three-stage process? The first stage is that you only change the file, but it's neither staged nor committed. Then you do the add command, and then you kind of gave the intention to save that file. So now the file is being tracked by the .git folder, but it's not actually committed yet. And then when you do the commit, it's actually saved, and then you can also synchronize it or push it to the remote repository, which Jordan will elaborate on later. Does that make sense to anyone? Or if you have questions, feel free to unmute yourself. Otherwise, I just saw someone gave a thumbs up. Maybe do that. That seems like okay. So let's do another change. Let's type nano mars.txt and add another sentence. This is new information. And we save it again with Control-O, Enter, and Control-X. And if we do cat mars.txt, now we have 2 lines. And now if we type git status again, we can see that the file mars.txt was modified, but it hasn't been added yet. So when you remember the graphic we had, it's at the first stage. And now we learn a new command, which is called Git Diff. It shows you the difference between the different stages or phases. So if you type Git Diff, You get a bit of random information at the start, but the most important part is here. So this is what the file looked before we did the modification to Mars.txt. And here with the plus, you can see what you added. So you can see like the delta of what you have before and what you did in the new step. And if you add the file now, let's say git add Mars.txt, and then you can double check, and we can see that now it's added because now it's green when you check the status. And if you type now git diff, you will see that you don't see anything. This is because there are two different commands. Let's go back to the graph. We use the Git Diff Command, and the Git Diff Command shows you the difference between the first stage, so when you have made a change, but it's not tracked by the .git file yet, and the staging area. But now we have staged our file with the add command, git add. That's why there's no difference between those two stages anymore. That's why the git diff didn't return anything. But there's a second command, or you can use git diff with flags when you want to check between the difference between the staging area and the level in your repository. And for that, you use the git diff staged command. So there, to check the differences between the three stages, you can use those different commands. So let's go back to the command line. And let's type git diff staged. And you can see that now you can see the difference again, because it hasn't been committed yet. And now let's commit the change. Again with a message. You should make more understandable messages, but because it's a dummy example, I will just write new change now. And now it's committed. So if we do git status, we would see that it's clean. And if we would type git diff staged, you wouldn't get anything because now everything is on the same level. But if we type git log, you can see all both commits that we did. And an easier version to use git log is a command that I like a lot is git log _1 line, because it's much more concise. Like when you only have 2 commits as we have here now, it might be good to have it more detailed. But if you have 20 commits that you want to look at, it's enough to have just the start of the commit identifier and the change. Maybe let's do a quick exercise to see if you guys kind of understood the commit concept. I'll just share the other screen. For the question here, so which commands below would save the changes of my file.txt to my local Git repository? 1, if you do git commit with the message. 2nd, if you do git initialize and then git commit as a subsequent command. 3, if you do git add and then the name of your file and then git commit. Or if you type git commit message your text and then the message. Maybe type in the chat 1, 2, 3, or 4, depending on what you think is the solution. Yeah, I see a lot of phrase in the chat. So let's look at the solution. So yeah, git commit, you can't commit something that hasn't been staged yet. And this file wasn't staged, so you can't commit it. And that's why 1 is wrong. 2 is also wrong because you would initialize a new repository which is myfile.txt and then commit it. So this just doesn't work. In 3, you exactly go through the 3-stage process that we discussed. So you do the adding to put myfile.txt into the 2nd stage and have it a staged file. And then you do commit to actually save it. And the last one, you would commit with the message, and then the file would be the message. And the name would be my recent changes. So this would be also more confusing. And let's go back to the command line. So the key takeaways, I think, of this section are the steps we did. That Git Status is a really useful command to check where you're at, which files are staged, which files are not staged yet. So if you work on multiple files, this can be really useful, giving you information on what tracking level each file is. And then in order to track the files, you use git add and git commit. And if you want to actually compare the difference of what you did to the previous version, you can use git diff. Oh yeah, you can check those commands in the text. And now let's go to the 5th section of the text. If you're having it open on your screen, exploring history. We already started exploring history a bit by using the log command, as you might recall, when we type git log, 1 line, or you can without the 1 line. So we were already seeing a bit the history of what we had done, of all our tracked changes. And you might see when you print the history that in the most recent commit, you can see the word head. And head stands here. It's the identifier of the most recent commit. You could kind of compare it with an alias. So it's the alias for the tracking number of the most recent commit. And when you would go into your nano editor again with the mars.txt file, and let's do another change. You can write more useful stuff, but yeah. And then we save it again and do cat mars.txt. We can see we have added another line. And now we can also use the git diff command with head. Let's say git diff head mars.txt. And we can also see that this is the change because we're comparing our mars.txt file to our head, so to our most recent commit. And the good thing about head is we can also use head with a tilde. So if I would use head with tilde and then 1, then I would not refer to my head anymore, but now I'm referring to the commit that we did prior to head. So to the commit on screen that is called start nodes on Mars. And if I click enter, you also see that now 2 lines are showed as added, because now I didn't compare it to the most recent commit, but to the one before. And like this, you can compare your current version to every commit you want by using the head command. Or instead of using the head command with a tilde, you could also explicitly use this number code, which is the identifier of every commit. Let's type git status again to just see where we are at, because we did some changes to our text. And we can see that we have a modified change, but we haven't added it yet. And we can put things back to how they were when they're not added or anything by using the checkout command. So if we type git checkout head morris.txt, it has updated one path. And if we now do cat morris.txt, you can see that this is new info and this is information about Morris. So this line, we add more info that we just added, but that is only in the first stage and is not in there anymore. Because we git checkout, we kind of reverted our local version to the version of head, which is our latest commit. And instead of using head, you could have also used again the code of the head, so the identifier. But I just find it easier to use head because then you don't have to copy paste that number. Let's do git, or let's clear first. Do git status again. So now it says on branch main, nothing happened. Because our change is gone, because cat morris.txt is now this information. Could everyone follow so far with the checkout that we reversed our local version by going back to head? Let's say if we did a mistake. Now let's see what happens if we have a staged version. So let's make a change again. Call it mistake. Say we made a mistake. And if we then print our master file again, we can see that this has been added. And if we check the status, we can see that it hasn't been added yet. It's in our file, but it's in the first stage. So let's change that using the git add command. Because if we then check for the status again, now we can see it has been modified. So it is in the staging stage. And now let's try to use checkout again. And now it has updated the path again. And if we then do cat morris.txt, we can see it's again reverted. And one important notice too when you use checkout is be careful to not type git checkout head, or instead of head, you could also use the number, like the code from above. So that's interchangeable, because if you do that, it worked now because I reverted it before, but if the change wouldn't be reverted, so let's say nano morris.txt, so let's do git add again. So now we are here on a different level than we are in our heads. And if then I type git checkout head again, it will ask here for Morris, but you might get an error message as well. My screen is going crazy. That's interesting. I'm not getting the error message, but usually you should be careful when you use git checkout with head with changes that are not committed, because then you get an error message that calls that you have a detached head. And if that happens to you, just type git checkout main.
Try
sorry,
try git status.
Did I lose it again?
Oh, yeah, you're right. Sorry.
Yeah, it should give an error message, but it suggests me to use Morse instead. Wait, let's try it with the number. Git log one line. Git checkout. Now I got the error. So now it says you are in detached head state, as I mentioned before. And this is dangerous because basically what we did now is before we were always only changing back the file Mars, but now we would have changed back everything that we changed in the commit. And this can get quite messy. That's why you get a warning. And if you want to reword that, you just type git checkout main. And then you should be fine again. Interesting that I'm getting this line because I never got that before, but I guess that's like the show effect. And what we were doing so far was always just making changes, like reverting the local version, but we didn't revert a version that was committed. But you can also revert a version that is committed, but you don't do that with the checkout command, but you do that with the revert command. So the checkout command what we did so far was returning files that are not yet committed and that are only within our local repository, because currently we have only been working within our local repository, and those were reverted to the previous state. And now we're going to use the revert command. And this command goes, you could say, one step further and reverse changes globally. So even changes that are already synchronized with your remote repository. And Jordan will show you how to do that in a bit. And your local repository, everything will be reverted to an old commit state. And you can choose to what you want to revert it to. So to be clean, let's commit our last modification here. That is only added, so it's staged, but it's not committed yet. With git commit message. And let's have a look at the log. And now we can see that the last commit is here and we have the commit ID. And the difference between reverting as well and checkout is, for the checkout, we were always putting the ID of the state we want to revert it to. So if we wanted to have the information from this state, we would put this ID. For reverting, if we want to revert, let's say, the last commit, we are taking the ID of the commit that we want to revert. So we would take this ID, revert this commit, and then we would end up being back at this commit. So let's type that. Git revert. And then we can copy this ID and enter. And now it asks you to write a message. So let's say due to mistake. And then we write it and quit. And now we can see that we did a commit. And now if we would have a look at git log one line again, we would see that we reverted the last commit. And if we have a look at our mars.txt file, we can see that the line where I stated mistake and which I also committed is gone. So we reverted a committed version to an old version. Did the revert make sense to everyone? I think that's a useful version, and that's a big feature of Git, which you don't have in Word, for instance, because as I said earlier, you have track changes, but you can't just revert to a specified version. And that's why it's also good practice in when you use Git to commit often, like if you made a logical topic and you made changes to that, make a commit, because if you have more stages, you can revert in case of an issue in a more detailed way. If you only commit, let's say, very big changes and then you make a mistake in the middle, you can't just revert it. But yeah, reverting is a very powerful tool. Did the reverse and the checkout make sense to everyone? Maybe let's check it with a quiz about checkout. Here, so I think everyone knows the project, or everyone working with Python knows the issue that you have worked with some code and you're super proud of your script and suddenly you accidentally break it and you don't even know what you have done wrong and you spend just hours to fix that accidental mistake. And let's say that Jennifer in this example has been using Git to keep track of her changes and she hadn't committed a change yet. So she wants to recover her last committed version and kind of not have her locally broken version anymore. And which of the commands would she use? Git checkout head, git checkout head datacruncher.py, which is the name of her file, git checkout head ~1 datacruncher.py, or git checkout and then the identifier ID of her last commit, and then datacruncher.py. Or would she use both 2 and 4? Maybe write again just your answer in the chat, just the numbers 1 to 5. I see a lot of 5s in the chat. So yeah, it's correct. The first one, git checkout head, would give you the error message of detached head that we had before. So it's not the right command. And then git checkout head datacruncher works because head refers to the last commit. So you would check out the last commit of the file datacruncher. The third command is not wrong, but it doesn't do what we want, because git checkout head ~1 doesn't refer to the latest commit, but to the commit before. So she would get an even older version, and that's not what Jennifer wants. That's why this answer is wrong. And the last one is git checkout and then the unique ID. And we said the unique ID is like you can use it interchangeably with the term head. That's why 4 also works, and that's why 5 is the correct answer. And you can also look here a bit more into a few details in the text if you want in your old time, into stage changes, the Git Diff Command, and a bit more into lock commands. Because a useful thing with the git log command is you can also, if you're tracking more than one file and it gets messy, you can only use the git log mars.txt, for instance, then you only get the changes that are actually connected to mars.txt. And this can make it more useful for you. So I think everyone understood it, I hope. Are there any questions to this area? Otherwise, I will pass on to Jordan to go on with ignoring things.
Thanks, Melissa.
Yeah, feel free to unmute yourself if you have any questions, or otherwise you can also write them in the chat when you have questions to this section, and I can answer them in the chat.
All right, so we will continue on with ignoring things and something called .gitignore. I'm just going to adjust my terminal so that everybody can see. Melissa, can you see my terminal there fine?
Yeah, all good.
Okay, great. We're going to start. So we're on, I think it's section 6, ignoring things, if you're following along on the web page. So we'll first start out with the make dir command, and we're going to make a directory or folder called results, and a couple of files as well. So touch command for making a couple of files, empty files at this stage. They don't contain anything. Okay, should work, looks all good. And then we will check how we're going on Git status. So now you can see we've got 3 files here that are currently untracked and 1 directory called results. And now we're going to create a git ignore file. And this is one way in which we can specify certain files in our folder. We might have some data that's sensitive, that contains sensitive information, and we're pushing to a public repository. So some of our data might have names, phone numbers, etc. And we want to make sure that that's stored away safely so we don't commit it to a remote repository on the web with public information. So we're going to use nano as we've been using a majority of these tutorials, a text editor to create a git ignore file. Once I've created one, I'm just going to exit back out. So I'm going to go straight to Control X here, and then cat.gitignore, and we should see. Yes. So our output, we are going to add in all the .dat files. So the wildcard here represents, could be any naming extension followed by .dat. And then we're going to add in the results as well to our git.gitignore. So this should cover a.dat, b.dat, c.dat, and the results directory. Now check git status, or cat rather, the git ignore. And we can see the files that we're interested in ignoring, so that we won't, when we go to add and commit and push to a remote repository, that we won't include these files. We can see on here that the git ignore file is the one that's untracked. Now we can go git add.gitignore, git commit, a message, ignore data files and results folder, the message, so that we'll remember. We put sort of informative message that we remember when we, in case later on in the project, when we look at the different versions we have, we remember the changes that we implemented based on that comment or that message, in case we might want to revert back to an old version in case we've made a few mistakes, as Melissa said previously. Status, so now that's been pushed to our local repository, or committed to our local repository. And so we will try add one of the files that's included in our .gitignore. So if you remember, we had the wildcard in there, which basically represented, could be A, B, C, D, E, F, G, doesn't matter to the computer. So we're going to try add git add .a.dat, and we're going to get a message telling us that the file is ignored by our gitignore file. So this isn't just an arbitrary file name here, it's recognized by Git. Git status ignored is the next command we're going to enter in. And this will basically outline to us in red here which files we have chosen to ignore. And we can see that there's nothing to commit and we're working on a clean tree. So there's quite a few, if you're following on the web page, there's quite a few quiz type questions. I'm going to jump through those as we are trying to get to a practical example using the our login access from yesterday to the Pawsey supercomputers. So we will skip on to section 8 or section 7 rather, which is going to be remotes in GitHub if you're following along on the web page. So if we can now open up in our browser, our GitHub account, we're going to create a repository through the web or browser interface. So if you're following along on the screen share, we're on github.com. Make sure you're logged in. If you're not, log in now. And we can create a repository with the big green new button there. So we'll click on that. And we're going to create a repository, a remote repository. So this one's going to be separate from the one on our local system. And we're going to call it planets as well. Checking through whether we want it public or private. We're going to go with the public repository for now. And we're not going to check any of these boxes. We're just going to click create repository. And then you should see this. This is a typical default page. If this is the first repository creating on GitHub, we can ignore a majority of this for now. We'll just go back to our terminal window for the meantime. One point I should say is that this process of creating the repository on GitHub essentially does what Melissa covered here. Not that we're typing this now, but that we did earlier, where we, on our local system, we made a directory, we cd'd into it, and we initialized a Git repository. So that is essentially what we've just done in the browser to get to this point here. So if you go into the browser here, we've got HTTPS and SSH. In the fashion following on from yesterday where we used SSH, we will click into SSH. You can see the text here changes, varies based on whether you have HTTPS or SSH selected. So please make sure you have SSH selected and you should see the Git at GitHub, your username, planets.git. And we will copy, we'll hit the copy button here. And we will go back into our terminal window. I'm just going to clear my screen here for convenience and clarity. So we're going to git remote add origin, and then we're going to paste into our browser. So for me, that's Command V on a Mac. Hopefully you don't have any issues with this. If you do have issues pasting into the terminal window, please comment in the chat for some help from Melissa.
We had a request if you could maybe slow down a little bit, Jordan.
Sure.
Thank you.
Does anybody need me to go back over any of the previous steps that I've just done? Okay, I'll slow down and make sure that we are not making any mistakes or missing anything.
Maybe just show the website again for how you created a repository.
Yeah, sure.
I think that might be useful.
On the tutorial or on the GitHub page?
Maybe on your GitHub account.
Sure. All right, so just redo a creation of a repository. So I'm going to go to just go home here, click on the home button. This is the github.com. I'm logged in, signed in to my GitHub account. I'm looking at my repositories. These are all of my repositories I've created. Some of them are private, some of them are public. I'm going to create a new repository with the green button there. I'm going to get a list of options for creating a new repository. The first one is got my username here, my GitHub account username, followed by a repository name. I'm going to try create planets again here. It's going to tell me that the repository already exists. So I'll just create a test repository here that I won't use. Optional description here. Then we have our public or private settings. So if you set it to private, only you and those you permit can view the repository. But the public repository is basically anyone on the internet can, as long as they have your username and your repository name, they can basically find your repository. We don't check any of these when we initialize a empty repository. It can make it more challenging, I guess, to sync up with an existing project that you have on your local machine, like the planets directory that we've been working on with Melissa in the first half of this tutorial. So we want to make sure that the remote repository we have out here on github.com is empty as possible so that we avoid conflicts and needing to merge things. Now I'll hit create repository and we get to this quick setup page here where we have our security protocols. And we also down here have instructions, which I did not elaborate on before, but it essentially gives us the command line instructions for creating a new repository on the command line, which is what we did with Melissa in the planets. In the first bit, we focused on these 3 commands here. And now we are focusing on the remote side. So we were working on a local repository on our local system, and now we are working on a focusing on remote repository. So one on GitHub, hosted by GitHub. And these are the command line or terminal commands for pushing in an existing repository from the command line to GitHub. So that covers the basics. I hope that that has caught everybody back up in case I was going too fast, and we can continue on now. So make sure that we clicked onto SSH here as we're going to set up a secure connection between the remote GitHub repository and our local machine. So make sure that you have SSH checked here, and the coloring's pretty subtle, but you should see the Git at GitHub. If you have HTTPS selected, you'll see the HTTPS text. So just going back to the command line now, this is the command we should be up to. So I've remote added the remote repository to my .git in the planets directory that we've been working on this morning. And now I'm going to check that the remote repository is the one that we will push to from what we commit to our local repository here on the local machine. We will then push to the remote repository, and we can also fetch from that remote repository. Okay, now we're going to set up SSH or Secure Shell, which is a cryptographic network protocol that allows secure communication between computers using an otherwise insecure network. We used SSH to access Magnus and Zeus yesterday, and so you should have a little bit of familiarity with how SSH can facilitate connecting to a remote system. So first, we're going to check on our local machine the existing SSH keys that we may have with the following command. So when I type in this, I'm getting the signal or the output that I don't have anything currently set up on this path. And that's what I'd like to see at this stage. If you've been working extensively with SSH or GitHub in the past, you might already have a SSH key set up, and don't worry too much. But if we need to troubleshoot that, please contact us in the chat or speak up. Okay, so now given that I don't have such a file, I'm now going to create or generate an SSH Keypair. Following command. And for this last bit here, it's important that you use the email that's associated to your GitHub account. So when you created your GitHub account on github.com, you should have an email associated to your account. So that's the one that we want to include there. If you want to check, that, I think something like some git config L, and it should have your user.email there in case you've forgotten and you want to quickly check and you don't want to go back into the browser. So git config L to check what that email is associated to our Git account. I'm going to clear, well, actually, I'll leave that up just in case anybody would like to see a bit more. Okay, so just going to, did anyone have any issues with the SSH keygen command? I'm just noticing here that I missed a line of the output. So I'm going to need to run back over this command quick. So I'm going to quickly reset or remove my SSH path here, and I'm going to rerun this command for everyone. So it's going to ask, so here it says it's generating the public private key pair, and then it says enter file in which to save the key. Here we want to hit enter so that we get the default, which is this .ssh file. So we'll hit enter here. And then it's going to prompt us for a passphrase. For more security, it's better practice to use a passphrase. If we just use enter, then somebody can access that. So the passphrase that you use, please note it down and enter it twice. You will not see the passphrase being typed as you go. That's just the nature of typing in passwords or passphrases in the terminal. And so then you should see this output once you've completed typing in your passphrase twice. This fancy little artwork here. And I'll just take a pause here in case there was a couple of things we did there. So in case anybody has any issues, please don't hesitate to comment in the messages or ask one of us on by unmuting yourself. All right, so the next command we can.
Sorry.
Yep.
Are you able to just go through after the key gen again?
Yep. Yeah, for sure. So I will, I'll run it all again. It's no worries for me. So I'm just going to remove the one I've just created. I don't recommend doing this if you've got your setup. This is just, I've reset everything on my local system. So I'll run through the whole key gen for you and all those steps afterwards. So pressing up here. So I'm going to key gen. Okay, now, so here we have the first thing it's asking us for is where do we want to save the key? And the default for your system should be this path up here. And you can specify that by just hitting enter here. So you don't need to write anything. That's going to be the default. So I'm just going to hit enter. Now it's going to prompt me for a passphrase. So I'm going to enter one that I make up that I'm comfortable with. Make sure I note it down so that I don't forget it. It's best practice not to save it anywhere on your computer. Unless you have some sort of secure password management system, which I'm not going to get into for now. I'm just going to use one that I am comfortable using and that I'll note down. So enter that in. Then it's going to ask me to enter in the same passphrase again. And now I'll see that the key has been generated, which is sort of signified by this fancy artwork here. I hope that clarifies the steps for generating a public-private key.
Yeah, that's great. Thank you.
Thank you.
I have one question.
Mm-hmm.
What is the ed to 5519 thing? It's in the keygen command.
Yeah, so it's, I believe it's the encryption algorithm used. So we're specifying what algorithm to use for the generation of the public and private key. There's a whole area of, I guess, public-private keys or key generation that involves. So you can think of the public-private key pair as sort of a lock and key. You have one of them is considered the lockout in that the public can see, but the private key is stored on your computer. And it's the only thing that can, when they communicate with each other, that can unlock that padlock. And so we're setting up the connection with our GitHub account, and the ed 5519 is the underlying algorithm that we've chosen to generate our keys. So
Cool, thank you.
Thank you.
So maybe one question, because I had it now twice in the chat, maybe just say it loud. There's some concern of your remove and the forced remove of the ~/.ssh command, if
Yes.
it might also remove other SSH keys that you might have saved, I guess, in the same folder.
Yes, absolutely. So if you have your SSH folder and you have other keys existing there, please do not use the rmrf-rf command. But for me personally, I had existing keys, but I've moved those to a backup path. So once I finish the tutorial, I'll move that backup back into my .ssh. So I hope that clarifies that. So if you've had existing keys, then you will not want to remove the ~/.ssh.
Sorry, just one more question, if that's fine.
One more question?
Yeah, so if we were working on, say, Magnus or a remote cluster, would we have to go through the same procedure of generating an SSH key pair?
Yes.
Or like, would that be, would the procedure differ at all if we were logged into remote cluster?
It shouldn't from memory. I have detailed it in section 15 of this tutorial. If we don't get to it in the time window that we have allotted. Please, if we don't cover it today, please check out section 15 and try follow those instructions to get it the same process occurring on Magnus or Zeus.
Yeah, all right, thank you.
Thank you. And now, so our lists with -al. Now I should see that my previously where I didn't have anything existing at this path, I now have my keys generated. So now we want to check if GitHub can read our authentication. So we're going to run this command. I'm going to type yes or Y. And we're going to get this permission denied statement here. So I'm just going to pause for a little bit and make sure that everybody's caught up or on pace. And the reason being is that we haven't yet given GitHub our public key. So we want to copy the public key. And this is the padlock that I was referring to earlier. We want to give GitHub our public key now so that our private key can authenticate our connection. So we do this. We can do this by typing in the following. And we want to now copy, we get this output here, 3 bits really. This text, and our account email. And we'll want to copy all of this and take it across to our GitHub account. So I'm going to go back into GitHub. I'll go into the home. I'll just give everybody a second to get onto their browser with GitHub. So at this stage, we should have this section of text from the previous output copied. And now we're going into GitHub to give our account our public key. We click on settings, which is this purple. For me, it's a purple icon, but you might have a different icon here, depending on your account. Then we're going to go down to settings. Once we're in settings, we'll go into SSH and GPG keys. If you have issues finding this, please let us know. We're going to enter a new SSH key. There are currently no SSH keys associated to your account, so I removed the one I had existing or the ones I had existing prior to this. And now we can enter in our SSH key. So we're going to give it a name. Jordan's tutorial. And then we'll paste in that text that we copied from the terminal here. And then we can lastly click SSH key. It's going to prompt me for my password, my GitHub password, my account password. So I'm just going to enter that in. And there you have it. You should see this output. If anybody doesn't see this, please let us know. It won't be the exact match here, but you'll want to see that you do have a key object present here. So I'm going to jump back into the terminal now. And I'm going to type in SSH T or -T git at github.com. So we can check our authentication again. Now that we've put the key, it's prompting me for the passphrase that we created earlier. So I'm going to type that in, asking for it. Oh, I've forgotten mine. I'm just going to read off my third time lucky. Okay, there we are. So hi, you should get a message. Hi, username. You've successfully authenticated, but GitHub does not provide shell access. Okay, so that's the message you should be getting that prompts you or notifies you that the public-private SSH is now successful and set up. Did anybody have any issues with that step?
Yeah, mine said permission denied again.
Okay. Melissa.
I would maybe suggest for those who have problems with SSH just to use HTTPS for this session so they can follow along, and then we can figure out the SSH issues later on, because you don't need to set anything up for HTTPS. Would you think?
I'm just wondering if it's going to request a PAT, a personal access token, for that.
Because that's the next step, right?
Yeah, it's probably to do with one of these steps where something's just a little bit off.
When you added the SSH key, was that entire line, including your email address?
Yes. So this, referring to this command here?
Yes.
Yep. So this should be your GitHub. So,
oh, sorry, no, not that one. When you copy in.
Yes. Yes. You're referring to this.
Yeah. Okay. Yeah. No, that's what I did.
Did you get your account email in here? I'm just wondering if it would be worthwhile getting into a breakout room now with you, or what do you think, Melissa or Edric?
It's not going to be possible because I've got the Zoom running on my laptop and I've got the terminal on a lab computer.
All right, I'm happy to, if you have some time this afternoon or another time, I'm happy to go over it stepwise with you individually.
Yeah, that's no problem.
And then we can go from there, if that makes sense.
Cool. Yeah, no problem.
Maybe then Jake just use HTTPS for now. Maybe Jordan just show quickly how it works, because that should work for everyone, because you just need to copy the link.
Sure.
And then everyone who has problems with SSH, maybe hang along after the session, and then we will figure out all the SSH problems afterwards.
May as well try.
Because it might be even very individual problems.
So to get to the HTTPS SSH again, we need to go to the repository we created. So we'll click on this icon here, go to your repositories. So this is not for everyone to do. This is just for those that are having trouble with SSH. Just going to go to planets, SSH, HTTPS. So now you should see this line of text here. Copy that. I'm going to open up a dummy. I'm just going to open up a dummy window here just to help you out, because I don't want to corrupt my planets one. Planets to just don't do this bit. I'm just doing this for purposes of showing HTTPS. Okay. Origin. Okay, so For you, you might need to remove the origin that you've set up with the SSH, which would look something like that for you. So just let me know once you've done that, and then type in git remote v, and you should see that you don't have any origins left. Are you good with that?
Yep.
Okay, so now we want to remote add origin. We should have the HTTPS one that we've copied from remote. And that is set up there. Did you have any issues with that one?
I think that's all good.
Okay, let's try. Let's just try for you. So, okay, so leave that for now, and then just follow along, and I think we'll be able to sync up, or if not, I'll be able to help give you a couple of little commands from there, but I think we should be able to sync up now.
Okay, thanks.
And then we can go through SSH into one-on-one at a later point. Thank you. Just bear with me a second. I'm just getting my bearings again. We're on the remotes and we're up to SSH. We've just got successful authentication. And now the next command we're going to enter in is git push origin main. We're going to try push the changes from our local repository that we were working on earlier with Melissa to our remote repository on GitHub. So it wants me to enter in my passphrase for the key, which is what we created earlier. And you should see that it has successfully pushed those files to the remote repository with a very similar looking output like this. If you didn't or weren't able to achieve this, please let me know.
I think Jake will have to use his personal access key now instead of the SSH key because he doesn't have the SSH key.
Okay, great. I included below, if you're on the GitHub page, I included that open command there. So let me share this. So we're at this point now all together. We just did git push origin. So for the personal access key, personal access token. If you just run this in your bash command, it'll take you to a sort of 5 or 6 step tutorial for creating your personal access token. So that's another way from SSH for creating authentication. That might take 5-10 minutes. So I think we may need to continue on. Here's a little bit about password managers. I noticed quite a few people are regular users of password managers. So this is a section that could be relevant for you if you are getting some sort of, or trying to want to manage your password in your preferred way, then please refer to this section. Here's going over the similar git add staging area commit repository, local repository. Then so as Melissa described earlier, but now this process is now we're using git push origin to extend this process to push that pipeline or that workflow to the remote repository. And we will try pull from our remote to our local with the following command. So we're going to enter in git pull origin main. As we've just pushed to the remote, we shouldn't see anything particularly interesting here. My typing is way off today, apologize. And already up to date, so we're not seeing any, we're not gathering any new data. Nobody's collaborated with us or pushed anything to the remote repository from our team, our fictional team of collaborators, and so we're already up to date. For me personally, I use the command line when I interact with Git and GitHub, but there is a GitHub GUI, which if you're somebody that prefers GUIs, then I do recommend exploring that further in your sort of own time with the project. So please do look up available GitHub GUIs. Do want to talk about the difference between a push and a commit. So in Melissa's section, we got up to commit, and we've now extended that to push. So we're going to, if anybody wants to try describe the difference between a push and commit in the chat, now would be a great time to do that. I'll give 20 to 30 seconds and then I'll reveal the solution. So how is Git push different from Git commit? Yep, all good answers. So the solution, when we push changes, we're interacting with a remote repository to update it with the changes we've made locally. Often this corresponds to sharing the changes we've made with others. Commit only updates your local repository, as we saw in this pipeline that we've got here from our initial file, staging area, local repository, and then to our remote repository on GitHub. So here's a summary of the key points from the section we've just covered. The remotes, GitHub remotes, and we're going to now move on for time's sake. So collaborating, I know a few of us are working on projects under the same title, and we may need to use GitHub during the Pawsey projects, or we might need to use it at some point in the future. It's a really good skill to have to really understand the scope of the power of GitHub. So I'm going to share, we're going to work in pairs for this little activity. So I'm going to share in the chat a file that pairs everyone up that I prepared earlier. So if you inspect the image file that I've put into the chat, you should see who you are pairing up with for this activity. And we will, if anyone doesn't have a partner in the participants, please put your thumbs up or speak up, and we will try, between Melissa and myself, we'll try allocate you a partner, or one of us will partner up with you. maybe a good idea to send your partner a private message in the chat, just so you are aware of each other. As we will need, one thing we'll need to do is go into our GitHub accounts through the browser and provide, so one of you is going to be the owner, one of you is going to be a collaborator, and we're going to need to provide access, manage access or collaboration access. Okay, so we've got one person in need of a partner. I'll just give another 15, 20 seconds to see. Okay, great. We can, how about Naomi and Aiden go together? Is there anyone else? So Naomi and Aiden, please form a partnership. And then, okay, one more. Christine and Raina, please form a partnership there. So Christine and Raina. And another 20 seconds or so. Hopefully everybody's aware of their partner by now. If you haven't, please send them a private message so you're aware of each other, and then we will continue on with the activity.
Just a quick question, Jordan. What do I need ready on my machine in order to work with my partner for that exercise?
Should just your GitHub account and your terminal window.
Okay, so I don't need to have connected the plan that's linked to the remote repository.
Not yet. We'll walk through that together.
Otherwise, I can quit. Okay. Just
Okay.
I should quickly do it.
Yeah. No need to do anything quickly. All right. So hopefully everyone has a partner now, and we can begin the activity. So if you go into your repository, I'll go into mine. Give me one moment. Where'd it go? Okay, so if you go into your repository, and I think if you click on, so you should see your username and the planets thing. You should also see, if you were successful in pushing, you should see your files in the GitHub. So when we created our repository, it was empty, but we now have our mars.txt and our gitignore file. And we can see our .dats and our results directory that are part of the gitignore file aren't included in here as well. So that was successful. So if we click onto settings in our repository, we can see we've got on the left tab here a bunch of settings. We're going to manage access, and we can invite collaborators. So one person in your pair partnership can be considered the owner. So invite one of you as a collaborator, and for that you'll need a username. So your GitHub username, for me it's Bjorn Makins. If I was adding Melissa Spear, then I would invite Melissa to collaborate on my project like so, or Edric, cannot remember what his Git username is, but hopefully you now have the ability to invite one of you, and please discuss or convey your Git username across to your partner. So one person should be the owner, which is, I'm in the position of the owner right now, and I'm inviting a collaborator, so the other partner, to access my account, or access my repository rather. Once that person is enabled access, the collaborator should be able to go into their terminal now and clone. Probably best to, so as you can see in the, if you're following along in the window, we're going to, it's okay to Git clone from your from the planets directory in your local, because we're going to specify a path to our desktop where we're going to have our partners planets repository. So I'll show you an instance of that. So for me, I can go Git Clone. Let me quickly get we need the link here. So if you go to your partner's Git repository, so I'll just give everybody a second to get to their partner's Git repository, which is the owner. So you want to go to this site. So github.com, your partner will own the owner's username, followed by planets. Once you're there, we're going to get the HTTPS URL here. Copy that, which is basically the same as this one here. Copy that, go back into our terminal, type in git clone, paste that link, and then specify a path where we want to save or clone the repository to. So I'm going to say test, or no, I'll just go Bjorn's planets. And now you should have your partner's repository cloned onto your desktop. And we will CD into that directory so that we can run our collaboration activity. What did I call it? Beyond's planets. We're going to create a file. So now we have our, as a collaborator, we have our partner or owner, the owner of that repository's repository download onto our local machine. And now we can make changes as though we're collaborating with them on the same project. So we're going to create a file called Pluto. So this could be someone you're working with in a project. This could be your supervisors adding a file to your project. Those are some examples. And we're going to type in, it is so a planet. And then you can either do Control O to write it out, and then Control X and cat pluto.txt to make sure that we are there. Hopefully everyone's on pace. If you're not, please don't hesitate to let us know. Now I'm going to add pluto.txt to the staging area, and I'm going to commit it to my local repository. And now I'm going to push the Pluto file that I've created, or that you've created, to your partner's repository, remote repository on GitHub. So hopefully you'll see that that's been done successfully. So in my case, I'm collaborating with myself, which is kind of weird, but I have pushed that change to the remote repository there. And then we'll just run full origin main as a from the owner's point of view. So the collaborator was the partner that just pushed those changes to the owner's GitHub repository. We now want the owner in the partnership to go into their terminal and pull those changes from the other partner, if that makes sense. So for me, that's going to be not in this Bjorn's planet, which is my collaborators repository. I'm going to go to this one, to my original of the owners repository, clear my screen, and I'm going to pull
Sorry, I've got an error after the git push origin main. It's got error. src ref spec main does not match any. And then error failed to push some refs to, and then the
Yep. Are you the collaborator or the owner?
the collaborator.
Collaborator. Okay. And after you try to push, that's the error message you got?
That's right, yeah.
Were you given manage access by the owner?
I'm not sure.
So the other partner, when we did the step, when we did this step, settings, manage access, add collaborator, then your partner should have entered your GitHub username here. I'm wondering if that could be it.
Yeah, so I got the invite and I followed along. Yeah, did the add notes about Pluto and
add notes about Pluto. I'm going to try jump back. Yep. So you did git add pluto.txt git commit. Did you commit?
Yep.
Did you do the git clone like so before?
Yeah, and looked like it worked.
And it's just when you do git push origin main.
Yeah.
Can you type in git space remote space -v? Tell me.
Oh, okay. So it doesn't look like it's connected to my partner's repository, but it's connected to mine.
No, that should be all right.
Okay.
When you clone, did you clone your own repository by accident, potentially?
No.
All right. I'm not sure exactly what that is. I think we may need to either do a breakout or a one-on-one so we can see your screen.
Yeah.
But we have only 2 minutes left now.
That's all right. Yeah, obviously keep going. I feel like I'm holding up everyone else. So.
No, you're all good. Just send me a direct message and I'll try link up with you later. Or a Slack message. Send me a Slack message. Okay. So here is just towards the end. So we've just finished the pull and file change. Okay. Yes, so you should have seen the where we are, my terminal. Yes, you should have seen this change from an owner's point of view. If you've had success in this activity so far, where your collaborators Pluto .txt has now been pulled into your, so the collaborator pushed the Pluto txt to remote, the owner's remote, and then the owner on their local pulled the Pluto.txt in from remote to their local. And you should see that this was successful with the following error message, output message. And here's the detail of a basic collaborative workflow, which we've got 1 minute left before we take a 15-minute break. And so I think we will stop there for now and we'll continue on with conflicts and another activity later on in the afternoon. So I think we have a 15-minute break, if I'm right, Melissa and Edric.
Sorry, I was just figuring out some issues with personal access tokens. I can actually share it with everyone. What I just shared, because I actually wrote instructions on how to create a personal access token, because I think a few people ran into problems because they used HTTPS before, and then now they needed their personal access token because it asks for a password, but it actually is a personal access token.
Yes.
I might send the instructions. They're not pretty because I did them for myself kind of a while back, but maybe just share them in Slack. And yeah, I think we have 15 minutes and then we have the, how's it called? The session.n advertised.
Yeah, so leadership, I'm just going to check in the Slack now if the link has been posted. Did everybody receive an email or?
I don't think there was a link posted or the email posted. Wait, I might just pause the recording.
Yes, please.